Alright, so today's lesson is on augmented matrix and row operations. We'll start with an augmented matrix. An augmented matrix is a matrix that is formed from a system of equations. So, for example, this system equation is a two-variable, two-equation system. Right? So normally, your matrix would just look like this, and you just write it in the order that you see it, and you typically want to keep x's in front and y's in the back. So normally it would just be 3, 2, 1, and -3. Okay, it's called an augmented matrix because we're augmenting the answers into the matrix. So you would add another column, or you would augment another column of 6, which belongs with the equation 1, and -12, which belongs with equation 2. And this is your augmented matrix. All right, so that's how you do augmented matrix. Sometimes it'll be kind of weird and it'll be kind of off. You might be missing something. You look here, you actually have a 3 equation, and then that means that typically 3 equations should mean you should have 3 variables. And I do have it. Here's 1, 2, and here's 3 variables. So we do have a 3 equation with 3 variables. Okay, so this right here, it's going to change into augmented matrix. And if you just go according to the rows, x is 1, y is -1, and there's no z here. Okay, there's no z. We're going to use 0. Okay, and we're going to augment that with the answer of -7. Okay, and same thing, there's no x in the second equation right here. So if there's no x, we give it a 0. The y is 1, the z is 1, and the augmented answer is 6. Okay, again, no x, no y, and there is a z on the last equation, and then there's the augmented answer of 5. So there's your augmented matrix. Okay. Sometimes you have to kind of fix some of these. So this one's about the same. You're missing some variables, so we're going to just skip that one because that's the same as the previous one. But like this one here, sometimes you're really gonna have to fix it because some of the variables are on the wrong side, and you got to put them all on the same side. Right. So writing our augmented matrix. Right. So see how the x is in the back? Well, we want x in the front, so we would put -1. Okay. We're just sliding it over. We're not actually subtracting it or adding it. Okay. And the y is 2, and there's no z on that first equation, and then the augment of the -5 as your solution. Okay. Second one, see how the x is on the wrong side? When we move it over, we have to subtract. So the x is going to be -7. There's no y on that second equation, and then the z is 3, and then the answer is just 2. And that's our augmented matrix row. And then the last one, again, the x is on the wrong side. We got to move it over. That'll be x, when we move it over, it would be -3. The y would be 5, and the z would be 0 because there's no z. And then once we move the 3x over, there is no answer. So there's going to be a 0 for your augmented matrix. Okay. So that's the first one. Okay. Okay, now, so that's the augmented matrix. Now we got to get into the 3 operations. Okay, there's only 3 operations for matrix rows. Okay, first one is you can interchange any 2 rows. So, for example, this matrix here. Okay, if you need me to slow down, just pause it and copy it. This matrix here, you can actually swap or interchange any 2 rows. So what I can do is I can go row 1, which is this first row here, guys. Row 1, I can move it to row 2, which is this one here. Okay. And I can also do row 2, move it to row 1. Okay. You can write like this. Okay. You can write it like this. Double arrow, meaning it goes both ways. Or you can just show the double arrow like this, which just means that you're swapping the 2 rows. Right? So if I'm interchanging these 2 rows, or I'm swapping the rows, then my answer, no cheating yet. Don't look at the next rule yet. You're swapping, then your next 2 rows, or your next answer is going to be 4, 5, 0, because that's row 2 swapped in place of row 1, and now row 1 is going to be in row 2. So 1, 2, 3, and this is your answer now. Okay, so interchange any two rows. Okay, what else can we do? Well, we can also multiply any row by a non-zero constant. Okay, meaning that we can multiply the whole row, okay, or the whole row by any number besides 0, a non-zero constant. Okay, so we can say, you know what? Let's go row 2. We're going to multiply that by 3. Yeah. So I'm multiplying any row, which is row 2, by a non-zero constant. And if I do that, I will get, so row 1 I haven't done anything with, so I'm just copying it down. But row 2 is what I'm changing. So basically it's going to be 3 times the whole row 2. So 3 times 4, 3 times 5, 3 times 0. So this is kind of like a scalar multiplication, except it only works on one row. Okay, so this is called a multiple of any one row by a non-zero constant. So our new answer is going to be 12, 15, and 0 times 3 is still 0. Okay, so this is the second operation that you can perform on a row. Okay, and the last one is the most important one. So it's going to get the work done for a lot of us. I guess that's it. Okay, but anyways, the last one. We can add a multiple of one row to another row. Okay, so we can add a multiple of one row to another row. So for example, we can say we're going to add a multiple of row 1. So we're going to add row 1 times, oh, I don't know, let's go 3 again. Okay. Row 1 times 3, and then we're going to add it, and we're going to put it into row 2. Okay, so this right here basically reads 3 times row 1 plus row 2. Okay, you might also see as 3 times row 1 plus row 2, and then arrow, meaning put it into row 2. Okay, but typically
Sean, we're done.
I don't write that.
Can we leave the call? Or we have to stay on?
All right, guys. So I'd take a little quick pause. So what we're doing is we're going to take, and like I was saying, I like to put it into the row that I'm going to be working on. So I'm going to be working on row 2. So therefore, I just put on row 2, and I don't need to draw that I'm going to be putting into row 2 because I'm actually putting it in row 2 already. Right? If I wanted to go to row 1, then I would put it right there. Okay? But I'm putting in row 2. So what this means is I will start with row 1. I use green. Okay, we'll start with row 1, and we're going to times it by 3. Okay, so row 1 times 3. And then I'm going to add it to row 2. So I'm adding it to the second row. Okay, so basically, you're going to get your solution that looks like this. Right, so 3 times 1 is 3 plus 4 makes 7. Okay, and that goes into row 2. Right. Okay, next one. Okay, I am going to be, let me group that together. Okay, so I'm going to be taking row 1, which is the number 2, timesing it by 3. Multiplying it by 3 is the correct way to say it. Multiplying it by 3 makes 6. Okay, 3 times 2 is 6, plus 5 gets you 11. Okay, and that goes into row 2. Okay, next one. Okay, row 1 times 3, so we got 3 times 3 is 9, plus row 2, so 9 plus 0 is actually 9. Okay, so row 2 has changed, and row 1 is going to stay the same because we did not change any of that. So row 1 stays 1, 2, and 3. Okay, so that right there is our 3 row operations for matrices. Okay, okay, and then yeah, so we'll stop there.